great session on tap for you here tonight. My name is Russ Festino. I'm a technical evangelist for Algorand. And we also have Sergey Gorbanov here. He's going to also help out with the presentation today. And a little bit about myself. I'm been a developer evangelist now for over 20 years. Used to work for Microsoft, as a matter of fact, in that role. And, I've helped educate, I think, over 1 million developers in my career and something like over 2,000 presentations. But I got to tell you, this is a first for me. I have never done a live presentation after midnight tonight. So, round of applause again for Hackathon. All right. So let's go ahead and get going. We got the team here. I'd like to introduce Oscar. You want to wave, everybody? Oscar's with PureStick. Sergey, you're going to go and meet him too in a little bit. Rochelle, right there, give a wave. Fabrice, hello, and then myself. Okay, so make sure you visit us at the booth if you got any questions about blockchain, okay, or Algorand. So borderless economy, borderless opportunity, and Algorand is defining the standard for blockchain technology. Okay. Get the goods. This one here you want to take a picture of as well. So we have the hackathon materials for getting started at our Algorand DevRel site on GitHub. If you go in that repository, there's one that says hackathon. That's the one you want to go ahead and download all the source code that I'm going to be showing you here today. Also, the SDKs are up at our Algorand site and on the GitHub. This PowerPoint deck, I actually have a slide share posted it to it, so that's the bit.ly for the PowerPoint if you want to reference that with a lot of good links in here. Also our developer site, developer.algorand.org, and PureStick is here. They're one of our partners, and they got some great API examples in utilizing the blockchain for Algorand. So the blockchain promise. Who here, after hearing Jack today, is excited about the blockchain promise? Show of hands. A few of you are. Okay, very good. For those that are wondering what it's all about, basically, it's blockchain is a tamper-proof because it's an immutable ledger. It has transparency because all transactions are public, and there's trust, right? There's no central authority needed, and we're going to go into that a little bit more. Ransomware attacks. Who here has been hearing in the news about ransomware attacks? Show of hands. It's becoming more and more common. City of Baltimore and over 25 other cities, $100,000 they were being held ransom for. So what's worse than a ransomware attack? Any guesses?
What?
25 ransomware attacks?
Well, I was thinking maybe, paying a ransom, right? That, when I saw this on the news, this was right now, I'm from Tampa, Florida, so this is fairly close to me, and the citizens were irate that they paid $600,000, right? So that they're saying it just opens the door for another attack, right? This is crazy. And why are these attacks happening? Well, they're centralized data stores, right? And the hackers are finding a way of getting through the silo, right? And getting into the data center. And this is something that needs fixing. There is no doubt about it. And how about identity theft? Who here has had identity theft happen to them? Anybody here or know someone that has had identity theft? A few people have. This is, again, becoming more and more common. What happens when you swipe your card at Starbucks, right? It goes to a front-end processor, then an acquiring bank, then a card association, then the issuing bank, then the payment processor, then the Federal Reserve, and then clearinghouse payments. There's a bunch of middlemen right in the middle of this thing. If any one of them has a security breach, there goes your DNA, right? And this is why this is happening. And I've had to change my credit card numerous times, right? My debit card for Bank of America. They say, oh yeah, it looks like someone got at it, and I say, well, how'd that happen? And they never answer how it happens, but it does. And look at this. It's a matter of statistics, right? That you're going to get hit with some kind of a problem there. So wouldn't it be nice to do some kind of direct transactions between the sender and the receiver, right? So think about that for a little bit, and we'll shed some more light on that in a minute. Then finally, what I want to leave you with here on the introduction to this topic is, you can communicate across the world in seconds, but sometimes it takes days to do financial transactions. And why is that? That's a problem. Another problem is you have erosion of trust. 92% of the millennials today do not trust centralized financial institutions. 92%. That is amazing. That's a very large number. And also, Jack talks about this in the session today too. It fed right into what we're talking about tonight. 2.2 billion folks do not have access to modern financial systems. This is a travesty. That's a big number of people. The cost and efficiencies to boot, add up to over $4 trillion. So we got some problems here. And I'm telling you, by you attending in this room tonight and picking up skill sets along blockchain, you're going to be able to help a lot of people. I mean, just look at this slide here alone. There's a lot of good things that can happen here by using the technology we're about to uncover for you. And so this is the agenda for the rest of the session here. We're going to start out with the blockchain basics, a little bit about what is Algorand and our consensus model. And then I'll pick up on the Algorand Foundation. I'm going to share a lot of great developer tools, including a number of our SDKs that we have for Python, Go, and Java and JavaScript. Also, we'll cover some of the APIs and command line tools that we have and what's coming up. So, with that said, we're going to go ahead and bring Sergey up. Come on up. Give a round of applause to Sergey.
Thanks, Russ. How many of you are thinking of building on top of Algorand? Oh, almost all of you. Fantastic. All right, so I'll tell you about basics of a blockchain. My name is Sergey. I'm a head of cryptography at Algorand. I'm also a faculty here at the University of Waterloo. So let's start with the basic problem, right? So you guys probably know what a database system is, right? How many of you know what a database system is? Okay, almost all of you, right? So it's a fantastic system, and it served us well for many years. And effectively, it says that you can write data and you can read data from a central repository, right? But the basic questions that a database system has to answer whenever you try to read or write from it is, well, whether or not it should give you the access to read or write to the data, right? A database admin usually sets up access control for this database, and the admin gets to decide when you get to read and when you get to write to this database. So as a result, the traditional databases are known to have effectively a single point of failure. If the database system goes down, then you won't be able to read or write to your data. If the administrator of the database goes malicious, then he can deny you access to the data, right? So for instance, if I want to prevent you from making a payment across the world easily, I can easily deny it. And I can tell you, well, you got to pay me, $10 to make a transfer through this database. It's very hard to access these things globally. Databases are usually centralized. You have a central system to which everybody reads and writes, and they're hard to manage and replicate across the globe. So what it is that we actually want if the database is not helping us? What we want is a distributed system that is secure, to which anybody can access. And that's exactly what a blockchain system is. Okay? So if you look at a high level, it's a system where data is organized in blocks, and blocks and the basic consist of sets of transactions. And it has properties that anybody can write a transaction, anybody can read a history of transactions, and moreover, everything is completely tamper-proof. Okay? So whatever goes into this database, nobody can go and change the history later. Right? You stamp it, you post it, that's it. Anybody can go and anybody can see that you actually have committed some data or a transaction to the system. Does that make sense? All right. So what are the basic blockchain properties? If you're thinking of building an application and when you communicate in it, then the basic thing you should keep in mind is that it's a system that allows a global instant access, right? Anybody can download a node in the Algorand it's called a node you can download or you can query a node, you can immediately see who wrote what data or who made what payments through the system. Not only that, you can write at the same time globally, completely. What you have by default are properties like immutability and trust built into this database. Okay? So if I'm somewhere across the world and you've never met me, and you promise me to make a payment or a financial transaction, then I can, by looking at this public ledger, I can verify whether or not you actually made the payment. I don't have to meet you. I don't have to wait, 36 or 24 hours for the banks to do the transfer. I can immediately get your money, and I can immediately confirm that you actually made the transfer. The other property that you should keep in mind is that it's actually very, very cheap to post data to the blockchain today, right? So in Algorand in particular, we can process thousands of transactions per second, and it will cost you like 1/1000th of an algo to post something, which is less than a penny. Okay, so you can immediately transact with anybody across the world and pay less than a penny for that transaction, which is incredible. If you look at international transfers, like even between US and Canada, you got to wait for days to do a transfer, and you got to pay, about $30. And it's virtually impossible to break the system, okay? So the system has been designed from grounds up to resist very strong adversarial models where for the adversary to break the system, the adversary will have to gain control of the majority of the entire network, which is impossible to do virtually. So what is a blockchain good for? So how many of you have an application in mind that you want to build on top of Algorand? All right. So I assume the rest of you want to build, but still looking for things. Is that correct? Yes. So here are some examples of what to think about when you're thinking about application. One is, of course, payments, right? So if you want to have a payment system or a payment network, Algorand could be your solution. You can automate payments, you can make sure they're cheap, efficient, and you can connect people from across the world to make these payments. The other use cases are notarization and storage. So if you want to post some data to a blockchain and make sure it's globally accessible by anybody, you can use a blockchain for this, right? So you can simply write data, and anywhere across the world, people will be able to read that data through an API and access it. You can order of information. So if you have a sequence of events, for instance, if you're tracking a shipment of a container through the globe, you want to know when the shipment has arrived and left a specific facility, right? So you can use a blockchain to do this. You can stamp information about when a shipment arrives at the facility, when it left. You can put information like coordinates and location in it. And you can build things like supply chains, right? So if you want to know that a particular, let's say, device and all the parts from it came from specific manufacturers that were credited, you can use a supply chain and build it on top of Algorand to track the entire history of all the parts of these devices. Okay? So here are more applications to think about. So payments. You can also do things like authorization of identities, right? So blockchain is great to track and record identities of people by effectively associating users with the notion of these public keys. A public key is an identity of a user that you can keep track through the blockchain. You can use a blockchain for voting. You can use it in self-driving cars or IoT communications when you want to connect multiple devices together. You can do things like multi-party transfers, billings. You can track assets. I think that's another very interesting application. So every one of you probably has a medical record, right? And you've been to a doctor in the past. So all these medical records today, when they're shared between doctors, it's a very cumbersome process, and it takes sometimes days to transfer your record from one doctor to another, right? Especially if you go in globally, for instance, to a doctor in a different country, good luck getting your medical record to that doctor. So using a blockchain, you can actually automate a lot of this and post information about your records to the blockchain so that it's completely globally accessible and people can read and write from it. You can use this to track things like car titles, right? So cars are often shipped from one country to another. They move frequently. They're being bought and sold. And whenever you buy a car, first question you should ask, well, has this car been stolen in the past? And you can use a blockchain to query that information, find out whether or not the car has been stolen. Some other interesting applications are waste management tracking systems or cross-organizational transactions. So when you have multiple organizations that have their own private databases, and if they need to synchronize any state between them, they can use a blockchain to do that. So if I were to kind of just give you a brief sense of some of the application domains, then you can think about healthcare, you can think about communication, real estate, or government records. All of these application domains have kind of a fundamental notion of records, right? There are records corresponding to titles, healthcare records, or communication messages or payments. And a blockchain is great for tracking all these records and making them immutable and secure. Does that make sense?
Yeah.
So you mentioned like healthcare applications, right?
Yeah.
So one question comes up like that, like privacy is a big concern, like healthcare stuff, right?
Yeah.
So since in the blockchain everything's like publicly available,
Yeah.
like how does that like play in with like privacy of like records and stuff?
Yeah, that's a great question. So if I just repeat so everybody can hear it. So the question was, well, if you have some data which potentially is private, like your healthcare record, should you post it on the blockchain or not? Because the blockchain is this public global ledger, right? And the answer is that there are a number of actually cryptographic tools you can use to help you protect privacy of your records. So for instance, you can use basic encryption techniques to encrypt the data before you post it on a blockchain, right? And then by kind of given only selected access to the secret keys, you can authorize only specific individuals that you want to authorize to be able to decrypt your record and see it in clear. So, and if you have more questions, we can kind of talk offline how to use encryption for this application. All right, so now that you know what a blockchain is, let me tell you what is Algorand. So if I were to summarize it, Algorand enables borderless economy, right? So you can create new types of applications where people can transact across borders without having to go through the existing legacy financial systems. So Algorand has been around for a little over a year. One of the main founders is Silvio Micali, who is one of the pioneers of the field of cryptography and an MIT professor. The project has started in academia and has been in works for a number of years until we assembled a team of business leaders, technical leaders, marketing, and engineering, as well as investors to kind of bring this project to life, right? So over the last year, we've been working trying to launch the network, and we launched it a couple of months ago. So Algorand as a blockchain platform is publicly available. It is listed on a number of exchanges. We also have test networks that you can go and build upon. So it is a blockchain that's developed from first principles, enables continued progress, where we have a number of new innovations that are going to be coming up in the future. So for today, the things to keep in mind about Algorand is that it's a pure proof-of-stake consensus mechanism. So for those of you who are familiar with things like Bitcoin that uses proof of work is a very outdated concept that wastes a lot of electricity and very, very slow and not very secure. That's a summary. So Algorand scales to billions of users who can process thousands of transactions per second, and any transaction is confirmed under 5 seconds. Okay, I think from the launch of the main network, our average confirmation time was about 4.3 seconds. And you pay very, very, very little per algo. Very, very little per transaction. So it actually costs you way, way, way less than a penny to do any transfer. So we don't have that much time, and I don't want to bore you with too many technical details, but let me give you one glimpse of the basic technical principle how Algorand system works. So by itself, Algorand is an effortless one-by-one Byzantine agreement at the core. And what that means is that every block goes through a special consensus algorithm before it's confirmed. And once the block is confirmed, it's immediately appended to the blockchain. Okay? If you know about Bitcoin, that it has things like forks or proof of work, how many of you have heard those terms? Yeah, quite a few. So forget about all those, okay? Those are nonsense. So no forks in Algorand, no proof of work. All the blocks are confirmed, and you can actually run a node on your laptop or your Raspberry Pi device. Very easy to run a node. You don't have to waste any electricity. So the things to keep in mind is a public and permissionless network, and that's what really enables it to be a global system. Anybody can come in, anybody can join, anybody can start posting data and reading data from this blockchain. There is no entrance fee, there is no subscription. Okay? You are just as equal to participate in this network as I am. All users can participate in the consensus, and that means that if you want to be a validator of the transactions, you can set up a node and be a validator. No problem. And there's very, very minimal computational resources required to run nodes, right? I run one on my laptop all the time. Oscar runs a Raspberry Pi at home. Very cheap to run. You can set up a node on your laptops, or you can query one of the nodes that we'll set up for you and give you access through the APIs that Russ will tell you later. So it seems wonderful, but how can that be, right? Suppose you have 1 billion users in the network. How can you possibly get them to agree on a block of transactions under 5 seconds? Well, here's a basic key idea if you want to sleep on it for tonight. And the basic idea is, using cryptographic methods, we're able to take a population of millions or billions of users and sample what we call a committee of verifiers in the network that's small and constant size. Let's say 1,000 people. And what these 1,000 people are going to do is they're going to agree on a block of transactions for the network. Okay? They agree, and then what they do is they use special cryptographic methods to digitally sign the block. So let's say they sign a block B5, and then the block is appended to the blockchain. That's it. I'm not going to tell you more details, but that's a high-level idea, right? So instead of having all billion people somehow agree, using cryptographic methods, we sample a small subset of people, agree on a block, and for the next block we'll do the same, but we'll sample yet another random committee of users to agree on a block of transactions. Okay? This committee agrees, somehow digitally signs it, and then appends it to the blockchain. And that's it. And that's how the network evolves. Okay? Even if you have 1 billion users, 1,000 of them are going to be online at any point in time. They're going to agree on a block using some consensus mechanisms. They're going to append it, and that's all you have to know for this talk. Yeah?
So does every member manually verify the transactions, or does it do it in the background?
Yeah, you never manually verify transactions. You have a piece of software that's running on your node, and that software downloads blocks and just verifies these digital signatures produced by others. You never actually have to go and inspect it. I don't think you can inspect 1,000 transactions under 5 seconds. So automate the whole process. So here's another overview of the same flow. Effectively, what happens in the network is that all the transactions propagate through the global network, right? So everybody sees every transaction that appears on the blockchain. We propagate it from one laptop to another using a peer-to-peer network. Then, when we want to agree on a block, what we'll do is we'll randomly choose one of the laptops from this network and ask that laptop, well, tell me all the transactions that you saw and tell me the block that you would like to assemble. This one laptop will assemble all transactions in the block, propagate it to other nodes, and then other nodes will somehow vote, as I said, or digitally sign the block of transactions. Not all of them, but a small subset, like of a size of 1,000. And then the block is added to the blockchain. All right, so that's all I wanted to tell you about the technology. If you want to learn more, then there are online links that will be available, and you can look up white papers on our website on Byzantine agreement protocols, or things like verifiable random functions, perhaps after the hackathon or during the hackathon if you actually want to understand deeper how it works. That's all I have for the basics of a blockchain. Any questions here? Yeah.
What's proof of stake?
So proof of stake effectively means that in the consensus protocol, how much voting power you have is determined by how much money you have in the system. So if you have 10% of the money in the system, then you're going to have 10% of the voting power to say which blocks are good or bad. That's what proof of stake is.
Another question over there?
Yeah.
So instead of data being stored on databases,
Yeah.
for example, would it be stored on each user's like device? So like if it was a phone, it'd be stored on millions of phones instead of just like in a centrally database.
Yeah, so the data by itself is going to be replicated against across all the nodes that run the software, right? You can, however, have like a mobile client that doesn't store the data, but it only queries other nodes that store the actual data itself, right? So as you build in an application today, let's say you build in a mobile, you don't have to actually run a node on a mobile device. You can use API calls to other nodes that we have set up for you, or you can set up yourself and query them and see what data has been read or written, and you can write data there yourself.
Is it possible to create like a totally internal blockchain where it's not connected to the global blockchain?
Yeah, you can create private networks, and I guess this is actually a good segue into Russ's continuation. He'll tell you kind of how to set up a node, what types of nodes are available, what types of networks you can create, and it's a great question.
All right, how about a round of applause for Sergey? So let's get into some of the tools, right? And a little bit about the Algorand Foundation. First of all, I work for Algorand Inc. That's the technology side of the house. And then also the foundation is like everything to do with the money side of the house. And we have a distribution schedule coming up of all the algos. We had an auction back in June. I think we had $60 million worth, I think, of algos were purchased. So our cryptocurrency is out there now. And also the last line there's going to be over 250 million algos distributed as end user grants, and that's primarily going to be going to the developer community. So let's talk about Algorand Testnet. This is where you're going to go ahead and start creating your applications and testing them out and developing. So at ROX, we've got worldwide distribution on our nodes. Also, we have some really great tools like the Testnet Algo Explorer. Allows you to search by block or by transaction or by account. And very easy to install your node. You go out to developer.algorand.org, and only probably takes about 10 minutes to install a node. And also some really great documentation up there as well. The process architecture, basically you have wallets and accounts that you can see here, and the wallets do not contain coins, right? They contain private keys, and specifically wallets are encrypted collections or addresses and their corresponding keys. And every node can have one or more wallets, but each node only has one default wallet. So a wallet contains things like a name, an ID, and a mnemonic. Also, a multi-sig account is possible. This is kind of like the scenario like when you go to cash a check, for example, and sometimes 2 signatures are required to cash the check. It's the same type of thing here with a multi-signature account. You can have numerous thresholds. The threshold is how many people have to sign off on it. So, an example too of that, we had a hackathon in Boston a few months ago, and one team came up with kind of a supply chain solution for for medicine. You know, because if medicine gets into the wrong hands, it could be deadly. And so they created a supply chain application that went right from the manufacturer to the distributor to the retail outlet to the patient. So that was like a 4 signature approach, right, to make that transaction legit right across the board. Participation keys, and basically what you have here is the VRF key, which is the verifiable random function that we use to create the blocks, and then that associates the keys to the account. And then after that, you have the generation of all your participation keys. You can use Goal, our command line tool, to do that as well. We'll show you that in a few minutes. The two daemons we have are KMD, that handles all the transactions interacting with spending keys, things like wallets, for example. And then the AlgoD daemon is responsible for processing the protocol and interacting with our SQLite to record the ledger, and that implements the REST API for read-only APIs. So then we get down to the APIs and command line tools. I love this slide because this really shows all the classes, methods, properties that belong in the Algorand blockchain. You can see several of them here with the rewards, balance. You can do a list of accounts, for example, multi-sig account we talked about, exporting and importing. And then also you can see on the bottom right, you would be your node operations, where you can start and stop a node. And then a little bit over to the left of that, as you see the network as well, right over here. And that is for the private network that you asked about, right? So private network, you can go ahead and create and delete and restart those. Wallet, you can be able to list, KMD, again, start and stop. Goal is the tool, command line tool, that really has access to all of these. And we'll actually demonstrate that in a little bit. And the private networks, these are primarily really for developers to learn from. It's not really a security thing. The word private doesn't mean like privacy. It just means it's your own. I think a better name might be personal network, right? That you can run just to test out your application. All the SDKs work with it, and that's a good learning tool. So SDKs and Swagger, our format for our tools is in Swagger format, so this will facilitate creating any client that you'd like to. And also you can import the Swagger file, the tools like Postman or PAW, right, to do some code agnostic testing, for example, some of the REST API calls. And the way you get at it is go ahead and fire off a command to go ahead and download the Swagger file. And then once you have that downloaded, you can then take it and import into tools, like I said, like Postman, or you can use it to generate clients. So those that are like using C# here, you could take that Swagger file, go out to the Swagger Hub site, import that Swagger file into it, and it'll go ahead and generate your C# client for you, so you can program in C#. So we have more SDKs coming out. Right now we have Go, Java, JavaScript, and Python. You can see all the different transactions that you can do. And also the SDK documentation is very, very rich. And that's, again, at developer.algorand.org. PureStake over here. We got some really good partners now in the industry that are working with us. And PureStake has a great interface for a node service that is archived as well as indexed, right? Is that right? And very fast, very quick, and you can use it right from test going into mainnet as well with the same token. And so good things there, as well as great APIs as a service. There's a lot of different plans here. They do have a GitHub repository that you can see there on PureStake/API examples. So you got some good sample code there as well. So now it's demo time. So we're going to go ahead and bring up this test here. And what this does, we're going to go ahead and get the latest block. So you can see all the block information come back, including all the transactions that are in there. Let's go ahead and generate an account next. And then we'll go ahead and get the account details. So there you can see the address, right? That would be that we saw like in the chess game. We'll copy that off. Then we're going to go out to our testnet dispenser, which is another tool. And you can actually see here, we're going to go ahead and pick out fire hydrants. This should be easy to do. All right, good. And the testnet dispenser is designed to go ahead and send out fake money, right, to these accounts. So now I got some algos in this account and if I go to recover with this mnemonic that we have up there, now you can actually see there's an amount right to that balance. So that will facilitate us doing what? Sending transactions. So let's go ahead and submit a transaction. So there's a transaction ID that's associated with it. And let's go ahead and get the information that we put into something called the note field. The note field on transaction is a free-form field that you can put any kind of information in. So if I go ahead and retrieve this, now you can see I've got a code that puts in the age, eye color, and first name. It's a structure, right, that I've created in the application that I'm writing out to this node field. And that is how you create layer 2 applications on a blockchain. So what we see here is a customizable area that pertains just to your data, just to your solution that you're building. And you can use this to store anything you want that's part of your transaction. So in the case of the chess game, this will be the move that the player just made, the piece, the position, all that kind of information is maintained in this node field. So that's where that is done. So let's take a look at this code. So I'm going to go ahead and go back out to the code here, and let's go ahead and go right up to the top here of this session. So when you are doing the hackathon, you're going to first create a node. And when you create a node, what's going to happen is it's going to go through a synchronization process. But you really want to create the node for 2 reasons. Number one, when you leave here, you'll have something to work with. It's going to take about 8 hours to synchronize. Also, when you do that process, though, you're going to create the KMD as well. And that's what you use for wallets and wallet transactions. And that is readily available instantaneously. So that you'll have to go ahead and put some corresponding code in. For example, right down here, you can see the KMD token. And this is actually found. I'll show you where it's found. Wherever you install your node, there is a data directory. And underneath the data, that is where, number one, you would see the AlgoNet. All right, so that is the token that you would use. That's the URL. That was localhost. But you said the token one is the Algo token. All right, so you can see that right there. The other thing you would look at then is in the KMD directory. You can see it right here. That is where you would find the token value and the internet value for that. So that is, those are the values that would you. Now in the hackathon, we've got it preceded with the hackathon token. So this instance is already set up, it's already synchronized, so you can go ahead and use this when you do your work. Then come down over here, take a look. This is the code that does the account information. So you can see I'm going to create an instance of the AlgoD client. And we're going to use the account information method, passing in the account. And then you can see we're going to go ahead and write that out. And that's what we just did when we executed the application. And then also there's the block status. So there's the status method, and going ahead and getting the block. And that's the route number we're going to go ahead and get it for. This is the code. Remember, I clicked on the create account button. So this would go ahead and take that mnemonic, go ahead and create the account. And this recovers it with that mnemonic. And this is the one that does the transaction. So here is the piece of code, right? This is going to be the object, the person object you saw in there with the first name, last name, age, and eye color. And we're going to encode that, and we're going to stick this on the note field, which gets passed in right there to the transaction. So pretty straightforward in terms of how you use it. And then when you go to extract it, we'll just decode it and get the transaction note right here. And there we use the decode method on that note, and that's what we saw print up in plain text. Okay, so that's it. I mean, what do we got here? A couple hundred lines of code, you know, for all this functionality. That's pretty good, huh? How about it, huh? Is that good stuff? Yeah. Okay. Next up, let's go take a look at goal. This is our command line tool. So here you can just do like a goal node status.
And how would you get goal?
What's that?
How would you get goal? Like the tool, command line.
How would you get the tool for goal command line? It comes when you do the install. Okay. Yep. So as soon as you set up a node, you'll have that available to you. Yep. That's a good question. Okay. And so now you can see right here, I just ran a quick status, and you can see that what the block number is, last committed, and it is actually. If you see the sync time greater than 0, that means it's still catching up, right? When you create a brand new node, as soon as you see it 0 consistently, then you can see that is in pretty good shape. So what we could do then is we could take a, like this block here, we'll copy it. And we have other tools that are available, one of which is the Algo Explorer. Let's bring that up. And there's a drop down for exploring either mainnet or testnet. So make sure when you're doing testnet development, you select that. So let's go ahead and paste that node in. I'm going to do a search, and up comes this with 27 transactions are in the block. So if I go ahead and click on that, then you can see the transaction ID, to and from information. If you drill down right into the transaction there, you can actually see the encrypted note field right down there as part of the transaction. It makes sense? It's a great tool, right? Especially if you are like writing transactions in the code and you really want to see if they happened, right? You can go out here to Explorer and you can verify it instantaneously. So it's pretty good stuff. Then let's take a look at a few of the other SDKs. So that was the JavaScript we covered first. Let's go into the Java SDK. So again, the same deal. You want to go ahead and set up your tokens that you have. And then we'll come down over here. And this is actually just going to do a simple get status. So let's go ahead and run that. And you can see the output come out down below over here. And there you can see the status, right, that we saw in the JavaScript example. Same thing. And then after that, let's take a look at Go. Well, this is just going to go ahead and give us our client information in here. We're going to make the client and go ahead and get a status. So let's go ahead and fire this off. And then we should see the same information coming out down below as well. And there it is. So that's our information down below. And finally, I'll show you Python. Now this one here is going to be a full example, right? We're going to go right through everything. It's going to actually create transactions. It's going to go ahead and do wallet transactions as well. So let's go ahead and fire this one off. So now we're going to see down below in the displays, right? So it created our block, created our account, and you can see all the information that's associated with it. These are all the transactions on that block. And then we're going to go ahead and encode a transaction. We sign it, and then we go ahead and have the transaction ID. Then we're going to wait a bit for the transaction to process, and then up comes the information for the transaction that we did. And once again, you would start out with your token values. If you are going to check out PureStake, you can just uncomment these lines right here and comment out the other ones. And I think you just run that here for Python. So you're in good shape there, as well as JavaScript, right, is the other SDK that is currently supported with PureStake. Postman. Code agnostic tools are great, especially at events like this, because you may have varied programming backgrounds on your team. Someone might be a C# programmer, someone might be a JavaScript programmer, and they're not too familiar with the language, right? So you're not quite sure if you have a problem, if it's with the language or if it's actually with the API call. So that takes all the guesswork away by having a code agnostic tool like Postman. So the lab exercise has steps on setting all this stuff up, and feel free to use it. But basically, here's the deal. You go ahead and set your endpoint up here. And this was the hackathon instance that we created. On the header, you got to put in the algo API token and then your token value, and then you just go ahead and fire this off. Now, first of all, when I created this, I did an import, and I imported that JSON Swagger file I talked about, and that's how I got all this stuff. So the only thing you had to do was go ahead and just paste in your URL right there, and it already comes pre-populated with the endpoint. And then you go ahead down to the header and you add these values right down in the header. That's how that works. There's a set of calls for the AlgoD REST API, and then there's a set of calls down here for KMD. So there's two Swagger files. And what you have here is another one here to go ahead and list the wallets. So there's all the wallets that get listed, same kind of deal. So anyway, I'm going to wrap up here. If you
Just maybe a question. Maybe you can just clarify for everybody at what instances they actually would have to set up a node today versus just using like a PureStake API.
At what instance do they have to set up a node versus using either the stand-up instance that we have with the hackathon or PureStake? So when you start a node up, it's going to take a while to sync. And that's really the biggest issue. And you only got 36 hours here at the hackathon. So
don't.
That would be eight hours wasted. No, I recommend you do still do it because that'll set up the KMD and give you the goal tool, right, when you do that. If I remember correct. It's been a while since I did it. But and when you leave here, you'll have that as well as another option, all right? So the hackathon instance will come down, but you'll have that. You can always change your code over. PureStake, you can just keep that right from the get-go, right? And then you have a site to go to for if you're going to mainnet or something like that. You want to talk about it for real quick? What your service does?
Yeah, so PureStake is since it is very difficult or consuming to have a node running on your own machine. So what we do is we set a front and an API front end in front of this service so that anyone that wants to use it can come and use it. And obviously there's APIs, there's many, or you can make millions of connections, or you can make very few depending on whatever your application is doing. But yeah, so we have the ability to we can control that and offer up the service for the public to use.
Okay, thank you very much. So let's continue here. Again, that's the to get the good slides. If you didn't get to take a picture of that before, go ahead and do it. And then we'll end up with some of the coming features that we have coming up. One thing we're working on is smart contracts. We usually get asked that as well as the Vault. This will help some of the blockchain storage issues on synchronizing, like we talked about, the time it takes to do that. Pixel, you got self-validating transactions, atomic swaps, post-sale trades, and I think named assets. I think we're working on too. So that would be down the road. If you are interested in becoming an Algorand ambassador, talk to Rochelle here. She'll give you information on that program. She runs it here for the States and Canada. And it's really great to get involved in the community. And this is one really excellent program to do that with, okay? And in summary then, what we see talked about here, we talked about what is Algorand, our company, a new blockchain company, one that's got a really killer blockchain. It's very fast, very great development tools we saw here today in the way of API usage and SDKs, as well as some great command line tools. We talked about testnet in the process, as well as the Algorand Foundation and our consensus model. And I think that is it. It is 1:29, and I want to thank you all very much for coming. Thank you.